So here basically the theoretical question, like either it will be theory based or it will be there are few proof that if there is a point C lying in between A and B, then prove that AC. So those type of question which you are having in your book. Okay, so I'm taking few question. Axioms are, options are, definition, theorem, universal truth, specific to geometry, and option D, universal truth. In all branches of maths. Yes, which option is correct option?
Universal truth.
C or D?
D.
Is it D? Rest of the students, is it D? Is it D? You can read it, read C and D really carefully, and then you can say yes. Vote for it. Is it C or D, or anyone? If you think A or B, you let me know. It is D. Okay, of course it is D. Yes, perfect. Because postulate, this terminology postulate Euclid have used for geometry specifically. Okay, those are also universal truth. This one is also universal truth. But axiom, this terminology you will find, okay, in maths, in like probability chapter, sometime in higher class, or in on a, other part of maths also, you will be able to see this terminology axiom. But postulate is specific to geometry, right?
Yes.
So option D is correct option. Okay.
Ma'am, theorem.
Is it theorem? Yes, it is theorem. Okay, we need the proof of theorem because definition is just a definition. Okay, postulate and axioms, universal truth. Okay, proof is not required. Yes, pyramid is a solid figure whose base is what?
Only a triangle.
Yes, triangle you said, Ryan.
Yes, ma'am.
Rest of the students, what you are thinking, please let me know. Only he is responding.
Ma'am, only triangle.
Yeah, what?
Only triangle.
Only triangle. Let's see. I'm drawing pyramids. I'm trying to draw pyramids. Okay, few pyramids. Suppose I have made a rectangle. Okay. This is how pyramid can look like, right? Right?
Yes, ma'am.
Yes, ma'am.
Rectangle is true. Okay, now let me draw a square. And this also looks good. Okay, it is a pyramid, right?
Yes, ma'am.
And what about triangle? Wait, let me draw it properly. Then only you will understand. Not like this. Actually, the base can be any polygon. Okay, and it can be triangle as well. Okay,
Okay, ma'am.
so you can see this is a pyramid, right?
Yes, ma'am.
Right. Okay, it's a pyramid. Okay, it's a pyramid, and the base can be any polygon. It can be rectangle, it can be square, it can be triangle, it can be quadrilateral, pentagon, hexagon, anything. Okay, polygon definitions are: polygon means the closed shape, okay, a closed bounded figure where we are, which is made up of straight line. That's called polygon, right?
Yes, ma'am.
So yes, okay, any polygon can be there. Next, Euclid stated that all right angles are equal to each other in the form of, is it a proof, is it a postulate?
Yes, ma'am. Postulate.
Okay, is it an axiom or definition? So if you have revised the axioms and postulate and definitions, you understand, you must know that it is postulate, right?
Yes, ma'am.
The statement that the lines are parallel if they do not intersect is in the form of, is it a theorem? Is it postulate? Is it axiom? Is it definition? If I have explained Euclid geometry to you, then I must have explained that the definition which we are having in book, apart from that, there are so many different definition given by Euclid. For example, the definition of parallel line, for example, the definition of perpendicular line. Okay, only few definitions are mentioned over here. So two such line which will never ever intersect, where the distance between both the line is always same, that is definition given by Euclid. Okay. Okay.
Yes, ma'am.
Okay, it is definition, option D. Now the number of interwoven isosceles triangle. Have you seen in the beginning of Euclid's geometry chapter, the history and everything is given about what happened in the Harappa Mohenjo-daro era, and what happened before that, how everything, the progress of this maths geometry happened. Have you read that part?
No, ma'am.
Okay, there only it is mentioned that what is Sri Yantra. Okay, Sri Yantra. So basically over there, when you will just read, okay, so many questions like doesn't come from there, nothing is there actually, just it is there that in previously, when nothing was known about maths, what exactly are the shapes, length, breadth, area, formula, okay, solids, pyramids, when nothing was known about the shapes, then also the shapes existed, okay, in the form of uh, like uh, previously they were worshipping Sri Yantra, which was like just a plate, okay, a rectangular plate where so many triangle were drawn. Basically, that's called Sri Yantra. People were worshipping that. Okay, it was consisted of triangle. I'm not sure you have seen or not. So let me check. Is it possible to show it to you or not? Just a second. Can you see?
Yes, ma'am.
So basically, this is something people were worshipping previously. Okay, this was giving maybe idea about the astrology or what, not sure. So here you, so that time, okay, later on they got to know about the more detail about it, but that time they were just not having any knowledge, just worshipping that this one. Okay, now here also we can see there are triangles, and that too isosceles triangle, you can see that, right?
Yes, ma'am.
So even without knowing the name of the shape, even without knowing, having that much understanding about the geometry, they were drawing such shapes, and that's an isosceles triangle they were drawing. Over this is made up of, like here inside this triangle, 9 isosceles triangles are there, which is just a sentence mentioned in that history part of NCRT. Okay, so if you will read, you will you will be able to see that yes, there was 9 isosceles triangle. Otherwise there is nothing which you need to read, you need to just go through it. Nothing is there, just this much. If you will do all the MCQ question and the question which we are doing today, you will be able to answer all the question. Okay, so basically the answer is options will be one, or maybe it is just the combination of 5 isosceles triangle where the option C is 9. So basically 9 isosceles triangle was there. Okay, keep it in mind, nothing else. Okay,
Okay.
boundaries of a surface are polygons, lines, curves, none.
Lines.
Surface can be like this as well. Okay, surface means maybe surface is like this, maybe surface is like this, maybe surface is like this. Okay, surface. Okay, so boundary of surface are what?
None.
None. Can we say boundary of surface are curves? Basically the curve, it is base, it is made up of curve, any surface. So what about this surface, the rectangle? See, curve means have you learned the concept of, just a second, no? In previous class, have you learned simple curve, and like what is the definition of the curve? So curve means what? Curve means without lifting our pen, whatever like shape you can draw, that's curve. Without lifting pen, if you have to lift the pen, that's not curve. So we can draw this one, it's a curve. We can draw a straight line as well, like this, without lifting pen, and this is a curve. Okay, straight line also just falls in the category of curve, because the definition of the curve is without lifting pen. If we can draw the shape, that's the curve. So the curve in our mind, curve means the line like this. It's fine, that is curve, but a straight line also falls in the category of curve. Getting it?
Yes, ma'am.
Okay. So keeping that in mind, we are saying that yeah, boundary will be curve. So it can be that curve as well, this curve as well. Surface means it can be any surface. Okay. Whenever this type of fill in the blanks question or MCQ question will come, please keep it in mind that straight line also falls in the category of curve, and surface means we are talking about any surface. When I have explained Euclid geometry, then I must have given the definition that one day we are having the thread, another day we are having the piece of cloth. So that's a surface for us, yes or no?
Yes, ma'am.
Okay,
Yes,
that's
ma'am.
a surface for us, and that surface is made up of curve. Okay, what about square, rectangle, triangle? So these are also made up of curve. Okay, because a straight line is also curve. Definition of curve is any line which can be drawn without lifting the pen, that's curve. So straight line is curve. The edges of the surface are point. Okay, this is Just a second. Just a second. Okay. This, read it carefully. It says that the edge of the surface. This is there in our definition, right?
Yes.
Okay. Exactly as it is, we were having the definition that uh, the edges of a surface are
Points.
surface. As it is, we were having the definition over there.
Line.
Okay. Yes, here it will be line. Okay. So the boundary of surface, we are calling it curve. Okay. Basically, boundary means, you can understand, we are thinking about like the total boundary, or maybe we are thinking about the straight line is also falls in the category of curve. And here, edge of the surface, we are just taking the definition as it is. Okay. Here also the confusion can be there. Okay, because of the previous one, that curve or line. But here we'll be having line, because as it is, the definition is given. Okay.
Okay.
Anyone having any confusion so far?
No.
No, ma'am.
Let's continue. Which of these statement, now I'm going to take a long answer type question for you, do not satisfy Euclid's axiom? Option A, things, let me zoom it, things which are equal to the same thing are equal to one another. Next, if equal are added to equal, the wholes are equal. Keep on reading the statement, and at last you have to tell me which is, what is given, correct or not correct. Satisfy. Okay, which do not satisfy. Okay, which is not correct. If equal yeah, these are the statements. Please tell me which one is not correct.
Ma'am, D.
Ma'am, D.
It is not correct.
Yes.
Okay,
The correct one is the whole is greater than the part.
of course. Okay, whole is greater than part, not smaller than part. Okay, so yeah, this is not true. Just a second. You will be able to do this question, right? In the given figure, if AC is equals to BD, then prove that AB is equals to CD. And the figure looks like this. Here A is there, here D is there, here B is there, and here C is there. Yeah, please do it.
Ma'am, done.
Yes, everyone done. This question we must have done during class as well, because this is like among the question. There are just few questions from Euclid geometry, and this is among that question. Okay, let me take few more questions. Just a second. Yes, rest of the students, are you done?
Ma'am, done.
Yes, Irshad, Bharti, Hanan, Sara, are you done?
Ma'am, I'm not happy.
How many line can be drawn through a given point?
Indefinite.
Yes, this one. We have given that AC is equals to BD, and from there we have to prove that AB is equals to CD. See, AC is equals to BD if you are having. Okay, if you will be subtracting, we need to create AB. Okay, so we will be subtracting BC from here, and the same BC we will be subtracting from BD as well, and we will say, okay, from axiom number, which axiom is helping us to prove it.
Axiom number 3.
Axiom number 3, what was that?
If if equals are subtracted from equal, the remainders are equal.
Yes. Okay, if equal subtracted from equal, if equal subtracted from equal, the remainders are equal. Okay, the remaining are equal. That axiom we are using over here, because we are subtracting same BC from both sides, from something which was already equal. AC and BD will already equal. From the equal, we are subtracting same thing on both sides. Yes, that axiom will help. If you will observe the figure carefully, you will understand that, yeah, AC minus BC. From the complete AC, if you will cut out BC, you will be getting AB. And from this BD, if you will cut out BC, you will be getting CD. Okay, so yes, this is the theorem which is helping us. Please tell me the next one. Anyone having any doubt over here? The proof part, which I just now I was explaining.
No,
Ma'am, can you show it again?
Okay, I said that. Yes, sure. I said that we will say that it is given over here that AC is equals to BD. Now, by using any axiom, we have to show the proof part. Okay, from the given we have to show that AB is equals to CD. Now we don't know how to show, so we are thinking that let's subtract BC from both sides. Now the question is it allowed all of sudden we are subtracting BC from both sides? So yes, it is allowed. If you are having one equation, x is equals to y plus 3, you can add same number on both sides, you can subtract same number on both sides. If you want, you can subtract one from here, you can subtract one from here, and yeah, your equation is not getting changed. You are not doing any drastic change, you are just doing an arrangement. Okay, it's just like a seesaw where both sides like same weight is there and it's in equilibrium. If you will keep 1 kg over here and 1 kg over there, you are not disturbing the equilibrium. It works like that. Okay, so we are not doing anything with this equality sign. We can subtract one from both side, or maybe we can add one from both side. Why one? We can add 20 on both side. Okay, and this way mathematically logically it is correct. Okay, we are not disturbing the equilibrium. So if we understand that, then we can say that on the basis of that concept we are subtracting BC from both side. By ourselves we are taking BC, and the same BC is nothing but just a length, a number. Okay, we are subtracting from both sides, and once after subtraction we are noticing that the AC, complete length AC, minus this BC, if we are cutting out this BC and removing it, we ended up getting AB. Yes or no?
yes, ma'am.
Okay, and we are on the other side, BD minus BC, the complete BD minus this BC is again CD. That's what we are getting. And what axiom we will use? So axiom number 3, that is, if something is already equal, if x and y are already equal, okay, it's equal. If something are already equal, if you are subtracting same thing from both sides. So if equal subtracted from equal, if you are subtracting k from here and k from here, if something x and y was already equal and you are subtracting k from both of them, so still, okay, the remainder will be, that means whatever will be remaining over here and whatever will be remaining over here, that will be equal with each other. That's what the axiom number 3 says, and we have used that axiom here in bracket. You need to mention the complete axiom number 3 says the complete statement you have to write. Got it?
Yes,
Okay,
ma'am.
Please tell me the next one. The next one. This one. How many line can be drawn?
A is infinite, B is 1.
Yeah. Yeah. Can you please repeat? Irshad, you were saying something?
Ma'am, A is infinite and B is 1.
Yes. Okay. How many line can be drawn through a given point? Through a given point, we can draw so many straight lines. Okay. Infinite lines. Two given point. So there is one and only one line we can draw through two given point. Right?
yes, ma'am.
Yes, ma'am.
Will you be able to do this? If C is midpoint of line segment Mn and D is midpoint of a MA, show that, let me draw the figure. Okay, it has to be MC, not MA. Yes, please do it now. Please try it.
Ma'am, could you explain the question?
Yeah, I'm explaining. Okay, the solution, right? Solution, right? Or the question.
Ma'am, this question.
Question. If C is the midpoint of line segment Mn, C is midpoint. Okay, Mn midpoint is C, and D is the midpoint. D is the midpoint of this much. This much midpoint is D. Then we have to show that this CD is nothing but 1 by 4 Mn. By using, okay, proper, by using axiom, postulate, only we can show it. Okay, already if you will see, you will be getting it. Okay, mathematically, logically, there is a chance that without even like without proper explanation and all, you are getting it already. But here we need here we need to use axiom. Please check it. I'll be explaining, don't worry. First you try it.
What is same in this? Uh,
Yeah, what?
How
What
to
is,
do this?
okay, let's discuss it. So let's see what can be done over here. If C is the midpoint, so for now we understand that this MC and CN will be same, right?
Yes, ma'am.
And if D is the midpoint, then for now we are getting that MD and CD will be same, right?
Yes, ma'am.
Okay. Now let's check what can be done over here. We have to show that CD is 1/4 of MN. Or maybe from here we can see, if we can show that 4CD is MN, that will also help. Okay. So just a second, let me check what will help over here. Just a second. I'm coming to the explanation part. Yeah. See what can be done over here. Okay. Better if we will take, okay, I'm explaining you how to do it. Okay, you check the easier version of this one. You will be able to find it. Otherwise, you can do it like this. So basically, what we can do, if if C is the midpoint of Mn, we can see MC is equals to Cn. Yes or no?
Yes, ma'am.
Okay. And if D is the midpoint of MC, we can write MD is equals to CD, right?
Yes, ma'am.
Okay, this
Yes,
much we
ma'am.
are able to write. Now we just have a certain set of axiom or maybe postulate, which we are bound to use over here. Okay, otherwise there are so many ways to solve a maths question, but here we are bound to stick to the axiom or maybe postulate. So over here, if we are subtracting it, what are we going to get? If we will subtract equation 1 minus 2. Now, which axiom we will mention while doing the subtraction? The same axiom which we have mentioned previously. If equal subtracted from equal, the remainders are equal, right?
Yes, ma'am.
Yes, ma'am.
Okay. So we can see that MC minus MD is equals to CN minus CD. This is what we are writing. Now MC minus, okay, axiom 3, you need to write in a statement form. Because something which was already equal, from there we are subtracting same from both sides, but we are not subtracting same. If you are thinking, then you must know that yeah, MD and CD are same, right?
Yes, ma'am.
So we are subtracting same from both sides. MC minus CD is MC minus MD is CD, right?
Yes, ma'am.
Yes, ma'am.
Okay, and here CN minus CD. Okay, So this CD I am taking to this side. We can say 2CD is equals to CN, right?
Yes, ma'am.
Yes, ma'am.
Okay. Now we don't need this CN over here. In our proof part, what is there? In our proof, okay, CD is there and MN is there, right?
Yes, ma'am.
Okay. So this CN, if you will try writing in terms of MN, either write over here in terms of MN or at first use equation 1. Using 1, you can do the substitution that Cn is Mc. Yes or no?
Yes, ma'am.
Okay. At the place of Cn, I am just writing Mc. Now I have not done anything else. Okay. Now we don't need this Mc in our proof part. In our proof part, this Mn, complete Mn is there. So can we write Mc is nothing but, okay, again we will end up getting, for now we can write Mc is nothing but Mn minus Cn, right?
Yes, ma'am.
Yes, ma'am.
Okay. This Cn we still don't need. Okay. So at the place of Cn, just a second, no, we will be able to take it easily. Suppose previously what I have done, just a second, let me check it. We were having just Cn over here, and at the place of that only I was doing the substitution that Mn minus Mc. And Mc then I was writing Md plus Cd. And we know that MD and CD both are equal. So we can write it as a 2CD. And then we were getting the proof. If you are understanding from the steps, great. Otherwise, I am coming to the explanation part. Okay, just a second. So see, okay, I'm not doing the substitution. I'm not doing the substitution over here. You can see we were having 2CD is equals to this 2CD. This is step, till this step it is clear, right?
Yes, ma'am.
Yes, ma'am.
Right? Okay. Then at the place of Cn, we are trying to convert it in Mn. Okay. Mn. Why? Because our proof contain Mn. So at the place of Cn, we can write, let me wipe this one. We don't need this now. Okay. At the place of Cn, can we write the complete Mn
Yes, ma'am.
minus
Yes,
Mc?
ma'am.
Yes.
Okay, Cn means complete length Mn minus this length Mc.
Yes.
Okay, so that's what I have written. That Cn means nothing but Mn minus Mc. Okay, Cn means Mn, the complete. Again, I am copy pasting the figure over here so that you will not get confused. So we were having M, we were having N, we were having the middle point C, and then we were having the middle point D. So at the place of Cn, I am writing Mn minus Mc. That means the complete length Mn minus this much. That is Cn only. We can see that also. Okay. Now in the next step, we are very clear with the proof that Mn is required, Cd is required. This Mc and all is not required. So directly you can write at the place of MC, you can write 2CD. Okay. You can write directly MC is nothing but this MD plus CD. Okay. MD plus CD. Either you can write this step as well, or directly also you can write it is nothing but 2CD. Are you getting it?
Yes, ma'am.
Yes, ma'am.
How? By using equation number 2, I think. Okay, by using equation. Now can you see we are getting this 2 CD will go to other side, so 2